All right, how's everybody doing? Awful. I can relate. All right, so bunch of stuff to go through. I want to do some review and make some comments on SLP and stuff like that. First of all, I started grading your SLPs, and they look really good. I have not gotten through all of them. I'm running behind, but I've got through about 2/3 of them. And those who turned them in, they're looking good. But a bunch of people have not turned in their SLP proposal. So, you know, there's up to 3 versions of this, so please go ahead and turn in your ideas, because you got to have this, because you got to work on it for 3 courses, right, for 3 quarters. You can't just eat the points on this, because it's a cross-course thing. If you turned in your proposal and it looked good and seemed to have all the necessary elements, then I probably just said something like, this looks great, go ahead. And I would have said, don't worry about turning in a version 2 or version 3. If you needed more elaboration on it, so if the project description didn't feel like it was actually giving me enough details to understand what you were proposing, I might ask you for more details on that. A number of people did not fill in the measure of success. So I've proposed 3 milestones, okay, 2 for this quarter, midway through and end of the quarter, and then 1 somewhere in the future. But I wanted you to fill in this table yourself, right? You can add more milestones, you can put in a future date, and then tell me what the measure of success is for those milestones. Okay, so you can't just leave this text in there, okay? That's not complete. But, you know, tell me, so my first milestone is to decide what language I'm going to do this project in. And what's the measure of success for that? I'll have selected a language, or I'll have narrowed it down to 3 possibilities, or I'll have selected a language and found a course that I can take online to learn it, right? Or something like that. So you want these to be very specific, and they're targets, right? And they may not be what you actually end up doing at that point, but they're goals, right? What would I want to accomplish by November 25th? Something more than, you know, have the prototype done. Well, what is the prototype, right? What does that mean? What does it do? If you're describing all of this, what part of that do you want to have working in a prototype? So you want to be as specific as possible in these. Bless you. All right, and cut off the top page, right? This is not part of your proposal up here. This is the instructions. So start down here. All right, so I pushed back the due dates for a version 2 and version 3 because I'm not going to have version 1 graded for everybody until probably Tuesday or Wednesday. So version 2 was due on Wednesday. I pushed that back to a week from today. Okay, and then version 3 is a week from Wednesday. So I'm putting some wiggle room in there, but I'll get feedback back to you as soon as possible. Check your comments, okay? If I gave you feedback, generally I did not put a grade in. So don't wait for the grade to trigger it. Turn on your notifications. All right, questions on the SLP? All right, let's look at the ODP. So Friday's ODP, there's no ODP today. Okay, we're going to take a break for a few days on ODPs. Friday's ODP, you were writing this function named start that basically processes command line arguments. And you could pass your command line arguments from main to start, and start would tell you if they selected a valid number, and then tell you what that number was. So different cases to check here. And I messed up on this. Because ODP 411, right, part of the point of 411 was if the user types in something like 5x, that should be a syntax error. That's not a valid integer. If they type something like 5.3, that's not a valid integer. That should be a syntax error. And so we talked about that last week, and you got that implemented in ODP 411, and that was great. And then in 412, I changed the code accordingly, but I failed to rebuild the test bed itself. So the test bed was accepting these as valid integers, and one of the tests was checking this case, so people were confused because it looked like what we were doing in ODP 411 didn't apply here. And that was my snafu. So people figured it out in Discord eventually that like you're supposed to allow this as integers, but that cost you some time. So if you did anything on ODP 412, right, I bumped your grade up to 125% instead of 100 to sort of compensate for all this extra work that you had to do because it didn't make sense. And then I fixed the test bed and I got rid of that bad case. So so that's why you got over 100% on that one. But let's look at the code for this. And it's similar to 411, right? So we don't really do a whole lot with argc and argv. Argc is just telling us how many arguments were on the command line, and if it's not exactly 2, that's an error. Because the idea is it's supposed to have one command line argument, right, which is a number. So if argc is not 2, we got an error, we can just return right there. If argc is equal to 2, we do have a command line argument, and what's it called? It's called argv bracket 1. So now we can examine argv bracket 1. We can't do this until we've done this check. If we don't do this check first and argv1 doesn't exist, this will segfault. So first we say, does argv1 exist? If it does, then we can go ahead and try scanning it as an integer followed by a string. And if that doesn't return exactly 1, it means it's not an integer. Either because it didn't find an integer in the beginning, so it returned 0, or it found an integer followed by something that's not part of an integer, and so it returned 2. So if it returns 1, we're good to go. If it's not 1, that's its own kind of error, and we just exit there. Otherwise, it returned an integer, which is now in the variable I, and so we can check the value of I and make sure it's positive. So positive means bigger than 0, and negative is less than 0. And anybody who says 0 is positive, they're not using the actual mathematical definition of positive, right? Positive means bigger than 0. So if I is less than or equal to 0, that's another error, and we return -3. If it gets through all those checks, then it is an integer, it was present, and it's not less than or equal to 0, so we just return the integer value as the value of the function. All right, any questions on that?
This isn't exactly with, like specifically what you were talking about, but I remember before you said that there's differences between this one and the bash one, and I think that one of them was that the program aborts after, like the user enters in, I forget which case it was, but
yeah,
there were several ways that the program could have ended in bash that you just wanted like there to not be checks. Like I think that it was the like entering more than what they could take.
Right. So so almost all the error checking is different now.
Okay.
So so first of all, the number of sticks you're playing with can come from a command line argument, or it can be entered by the user when you run, when the program is running.
Yeah.
Okay. If the command line argument is given, it's got to be exactly the only argument on the command line. It's got to be a valid integer, and it's got to be at least 10. Okay. If that is not the case, print an error message and you're done. Okay. If there's no command line argument, then you ask the user how many sticks do you want to play with. And they get one chance to put in a valid positive integer, bigger than or equal to 10.
And then if they don't, then
and if they don't, print an error message and you're done.
Okay, you do want an error message though?
Yeah, yeah. Don't just go silent. Okay, when they're specifying how many sticks they want to take, it's got to be a valid integer between 1 and 3, but here you do not give up on them. You keep asking them until they get it right. Alright, so if there's any problem with their entry, re-ask and keep trying until they make a valid entry. So there's no give up after 2 tries or something. So yeah, that's very different.
Okay. So the only two ways that the program will end is either if they put in an invalid amount of sticks, or the game ends by playing.
Mm-hmm.
Okay.
Yeah, an illegal entry for the sticks, either on the command line or when they're prompted for it, or the game ends because somebody won. All right, let's review fgets and scanf and make sure we're okay with that. It's gonna be one of these days I can't spell.
I was gonna ask,
Yeah.
what's standard OP?
Yeah, right. It's a secret. Okay, so let's talk about fgets first. Okay, fgets is the way to read a line of input from the user. Okay, this is not a command line argument. This is while your program is running, you want them to type something, hit enter, and you want to see what they typed. Fgets is the way to do that. Okay, you can use getcar, but getcar only reads a single character, and almost always you want to read an entire line. So we're just going to play with fgets. So it takes three arguments. The first is the name of a character array into which the user's input will be stored. The second is the length of the character array so that it knows not to do a buffer overflow. So if you try to put in more than 120 things, it'll chop it off and only use 120 elements in the array. And then the third thing is what you want to read from, which for us is just standard in. So two-line program, we'll do fgets to read from standard in, and then we'll print out what fgets stored in temp. So run it, and there's no prompt. Hello, what is this? And it says, you said, hello, what is this? With a new line at the end. So if I just hit enter, it says you said, and it's just printing out a new line. So let's print out the length of that array temp using string length. So I'm including string.h. So this is a little annoying. So string length technically doesn't return an integer. It returns something called a size underscore t. But it's basically an integer. But my compiler warning is saying, since I'm printing with a %d, I should be passing it an int, but I'm actually passing it a size underscore t, which is a long unsigned int. So I should use something other than %d for a long unsigned int, but I'm kind of pig-headed, so I'm going to do something different. This is where I can do some casting.
Who's casting it?
So casting says I'm going to put a variable type in parentheses, and I'm going to say take the bits that came back from string length and pretend it's an integer instead of an unsigned long. And now the %d is going to get paired with something that's an integer, and it should be happy. And it's a little sloppy. If my string length was bigger than what could fit in a standard int, I'd get an error, but that's not going to happen. And so we'll cast once in a while. We'll do it a lot in 222. But don't use it recklessly just to get rid of warnings. Make sure you know what the warning is saying. But I have confidence that an integer will work fine here. So I can say hello, and it tells me you said hello, and the length of that is 6. So HELLO, and a new line, and if I just hit enter, you said new line, the length of that is 1. Okay, fgets also returns something, just like scanf. It has a return value. So fgets returns a char star. Alright, so char star s, that's the thing we're storing into, that's the size, that's the stream, that's what stdio is, it's an input stream. And the return from fgets is a char star. Fgets returns s on success, null on error, or when end of file occurs. So on success, it's just going to return this first argument, s. But if something goes wrong, like if I hit the end of my input, then it's going to return a null. I'm going to really upset my compiler now, because an integer is not a pointer, but I'm just going to pretend it's an integer. So I'm going to take the value that fgets returns, I'm going to save that in this integer called retval, and I'm going to print that out at the end. So let's look at that return value. Let's see how upset it gets. That's not too bad. Okay, so I'll say hello, and the length of the entry was 6, and retval is some weird number. Well, that's some memory location where my string temp is stored. And if I run it again, I get a different location, right? Because these things move around. And if I make an empty line with just an enter, retval is still some location in memory. Okay. But I can do the following thing. Instead of typing in something and hitting enter, right here at the beginning of the line, I can hit Control D. Okay, Control D is how we signal what's called end of file. So I'm going to hold down Control and press D, and that's going to tell the system, I don't have anything to say. You've reached the end of the input. There is no more input coming. Okay, if this was coming from a file, it would say you've already read the last line of the file, and there's nothing more in there. Okay, if you're typing stuff in and you want to signal that same state, you hit a Control D at the beginning of the line. And we're not sending a Control D into our array, right? Control D is just a way we're signaling input's done, end of file. So if I hit a Control D, my input is empty, but most significantly, the return value from fgets is 0. And that's how you know that you hit end of file. Yeah.
If you were to hit enter, it would just keep going, or?
If you were to hit enter?
Yeah.
Hit enter, and it says you said new line, and the return value is wherever that got stored in memory.
Control D does that, but like enter does not.
Yeah, because enter is considered input. You could have a file with 100 lines in it, and each line is empty, but that's not the end of the file. So it'll just read that, and it'll say there's a new line here, there's a new line there. But then when you get to the end of the file, if you try to read any more, it'll say you hit the end of the file.
So it's kind of like how scanf gives you whether or not it fits the variable type you're giving.
Yeah.
This just gives you the location that it's at.
Yeah, so it's really just a flag.
Huh.
And if it's equal to null, then you know that there was no input. And you should not look at your buffer temp for anything meaningful.
That's what fgets returns.
That's what fgets returns. So we can do something like this. we can say, well, fgets, that stuff is not equal to null. Well, it doesn't return null. Well, if it doesn't return null, we actually read something, so we can print out the value of temp, and we can print out the length of temp, and we can go back to the top of the loop and call fgets again. And fgets will sit there and wait for us to hit enter, and when we do, it will store our characters in temp, it'll return something non-null, we'll execute the body of the loop, go back to the top again.
So technically speaking, you just use that and read out the entire contents of a file,
Mm-hmm.
whatever.
Yep.
Cool.
So I can say hello, this is fun, haha, yeah. And then if I hit Control D, that kicks me out of my while loop.
Does it? And fgets always stores information as a string,
Mm-hmm.
and that's why you need to cast it to get.
That's why you need to use scanf to like convert it to an integer, for example. Because everything fgets returns is just a string.
You'd have to use scanf.
If you were trying to read integers this way, you have a string, it might contain the character 5, but you can't multiply it by an integer. You have to turn it into you have to create an integer that's equal to the value represented by that string. That's what scanf does.
Oh, because if you cast a string as an int, then it just takes the ASCII value.
Right, right.
Okay.
So yeah, let's try that. You got a question first?
Oh, yeah. So what happens if we go over unequal characters?
Oh, so let's assume that we're only allowing 5 characters to come in. Okay, so let's run this. And I put in a whole bunch of characters here and hit enter. Well, it eats the first 4, right, because I asked for 5 characters max, and it needs 1 character for the null terminator. So it eats the first 4, stores that in my temp array, puts the null terminator, shows me ABCD, said the length of that was 4, and then it goes back to call fgets. Well, those other characters I typed are sitting in what's called the input buffer, right? They're in a holding area, and fgets goes to that holding area, and it finds the next character is the FGH. Reads those, loads them into temp, goes back up, looks in the holding area, there's IJKL. Goes back, there's MNOP, goes back, there's the enter. And now it's looking for more characters in the holding area. There's nothing in there. But if I type something here, right, and then I hit enter, all of that will go into this input buffer, this holding area, and fgets will read the first 4 characters.
I'm doing that and I'm getting the stack smashing detected.
Did you change your 120 in both places? So yeah, I changed it for both the array and in fgets. If you have it like this, that's exactly a buffer overrun, right? Because I'm saying you can load 120 characters into temp, but temp's only big enough to hold 5 characters, right? So that's
just as bad as using gets.
That's just as bad as using gets, yeah. Right, that's effectively what gets does is sets that number to infinity. All right, so let's square things. Right, so this is certainly not going to compile, right? Temp is a character array, I can't multiply it by itself. I can't even get an executable program out of this. Wonder why my display is color coding now. That's a little weird. a different terminal. Okay. Right. So I can't compile this. So I could try doing this. Right, if I cast temp to an integer, I'm not actually converting it, I'm just saying take whatever bits you find inside temp and pretend it's an integer. So let's square things. So I put in a 5, and 5 squared is this ridiculous number. And 0 squared is exactly the same number. And if I run it again, I get a different ridiculous number. Right. So what it's really doing is it's taking the address of my array, taking the address of that first element, and that's what's being turned into an integer. It has nothing to do with the contents. So so read from standard in until end of F, end of file. So let's convert the input to an integer. Alright, so we'll scan temp and we'll save that as an integer. And then let's just stick with %ds. I'm going to post this code, so. Okay, so we'll print out num and num times itself. By the way, a % sign in VI takes you to a matching parentheses or brace or bracket. So if I'm down here and I hit a % sign, it'll take me up to the corresponding bracket.
Nice. How do you do it again?
Percent.
Just percent, that's it?
Just percent. Kind of looks like two things.
Oh, yeah?
Yeah.
Got it.
Oh, yeah.
And that's useful for, like, you know, horribly nested parentheses.
Huh.
All right, so this should successfully convert our string that we got from fgets into an integer. So I can put in 5, 5 squared is 25. I can put in 67, 67 squared is that. Negative 2 squared is that. If I put in ha-ha, it says negative 2 squared is 4. Why did it do that? Seven squared is 49. If I put in ha-ha, it says 7 squared is 49.
Because it's not an integer, so it takes a lot of input and it takes a lot of stored data.
Yes. So scanf does not change the value of num if it doesn't find an integer. So we were saying scan our string, look for an integer. If you find one, store it in num. Well, if it finds ha-ha, that's not an integer, it doesn't change num. So num is whatever the last value of it was. So how can we notice that? We can do the following. Save the return value from scanf in result. And if result is exactly 1, So if result is 1, we'll go ahead and we'll print out the square of the number because we know it's an integer. Otherwise, we'll say it's not an integer and we'll show you what you entered. So 4 squared is 16, 5 squared is 25. Haha, says not an integer.
Nice.
And every time I do this, when I'm done and I want to exit, what am I doing? I'm just hitting Control D. And Control D is kicking you out of your while loop. So we can say goodbye. 2, 3, 4, and then Control D, and you're out of your while loop.
I have a VI question.
Okay.
I see that on there a lot, when you make typos, you're able to just highlight where the typo is and then type, and then it fixes it. Like just then where you had the capital O.
Oh, so tilde will change case.
No.
So you can hit tilde and it'll alternate. And you can do like, 100 tilde and it'll do 100 of them. So it'll basically do the whole line. And then a shift U will undo that if you don't move off the line.
Can you do something similar but change the letter?
Just change one letter.
Yeah, like if you type. Yeah.
Yeah, so you can hit an R and then you can type one letter to replace.
Cool.
And you can type a Shift R and start replacing and end with escape.
Cool.
Yeah.
Thank you.
Alright, so F gets S scan F. Does that help? Okay. So we talked a little last class about, last period about argc, argv, and sort of breaking that apart. Well, let me pass around a sign-in, because I think everybody's here who's going to be here. So don't actually sign your name. There's no line for signing. Just fill in the circle next to your name to show you're here. So last period we talked about argc, argv, and how to sort of break those apart and what they do. You can look at the end of that video if you're interested in that, but we don't really need that yet for 224. We really just need to think argv is an array of strings, and argc tells us how many things are in that array. So if argc is 5, we can look at argv bracket 0, 1, 2, 3, and 4. Okay, that's 5 strings, and each of those will be the strings in the command line that you use to run your program. So let me finish up talking about VI, and then I want to start talking about Linux. So remind me, if you can, how much did we talk about VI when we left off last week? Did we talk about copying something to the yanked buffer and then pasting it with a P? I feel like that's the last thing we did.
I think we talked about it a different day.
Okay.
It was like, you talked about how you could like take 5 lines.
Okay. So yeah, we can like take 2 DD to delete them, and then we can say P and it'll paste them after the current position. So that's like a basic copy and paste. And we just talked about change case. I don't know if I talked about it before, but tilde changes case on a line.
That's crazy.
Yeah.
Does
Did
it
we-
always change it to uppercase?
toggle it.
No, so if I go back and I do that, it'll toggle it back. And if you just kind of sit on the end of a line and just bang on that, it'll just go back and forth. So cheap video games. All right, Control G tells you where you are in a file. So if you hit Control G, it'll say it's a 24-line file. You're 75% of the way through. Over here on the bottom right, it tells me I'm on line 18, column 33. And it's reminding me my file's been modified. I haven't changed it since haven't saved it since I made some changes. Yeah.
So every time I try to do like the line number and then N, it says that pattern isn't detected.
So something like 3 and then an uppercase G will take you to that line.
Oh.
So it's G for go. Did we talk about Control L? That would be a no then. So you can say who, and you can see who's logged into the machine, right? So there's everybody who's logged in right now to the server. And I'm on there down at the bottom, Nick, and this window is logged in as test, which is near the top. So you see somebody logged in and you want to say something to them. I can just say write Nick, and Nick gets a message saying message from test, right? And I can say hello, what's up, and it pops up on their screen.
Someone write Nick right now.
I'm sure someone is. There we go. Thank you.
I'm doing it right now.
Yay.
How do you stop
Alright,
it?
my bad.
How do you spell
So this is cool until you're like editing a file. Go ahead, keep saying something. There we go. So you're editing your file and you like walk away and you come back and you're like, what? Right? So this is not changing my file. Okay, this is just appearing on the screen. So a really useful command a lot of places in Unix is Control L. Control L is a refresh. So there's all this stuff on here. I can just say Control L and it redraws the screen for a few seconds. All right, you can also say, you can say MESGN, messages no,
Nice.
and now if I try to write, it'll say Nick has messages disabled. Now once someone's writing to you, they can keep spamming you, so. But if you say message N, nobody new can start messages. And then if you want to go back to being social, you can just say message Y.
So instead of the Discord, we could just use the server.
So you can use this, yeah,
Got it.
but yeah.
Is there a write all?
No, but you could do that with Linux.
Oh, hey.
Because you can say who.
When you have two people messaging at the same time, it throws everything off.
Yeah, it
It's
can.
better than Discord.
Shut up.
So there's a list of all the people who are logged in,
Nice.
and I could just write, back quote that, and it would write to everybody.
Nice.
So, hi everyone. All right. So Control L is useful when you're inside VI, but it's useful other places too. That redraws your entire screen. All right. What else do we have? Uppercase J is for joining two lines. You have two lines and you want to put them together. Go to your first line, hit a Shift J, and it brings the second line on the end of the first. And if you think that you're moving down with a J button, but your caps lock is accidentally on, you end up doing this.
Oh, yeah.
And you can like turn your whole file into a single line.
Is there, can you undo all that?
So I can do a Shift U because I'm still on that line. Nope, I can't because I changed lines.
Yeah, it looks better
So-
than that did, it's fine.
So colon Q exclamation mark and go back into VI. So that's a bit of a bummer caps lock thing. Let's see. So substitution.
How do you exit this again?
Exit.
The talking sheet?
Control D.
Control D?
Yeah. So that's your usual end of file for most utilities.
Wait, but it's not working.
It's got to be at the beginning of the line. I don't know where you are.
Yeah, me neither.
Try Control C.
I would, but no.
He told me to. He told you to.
Yeah.
I don't know. Scroll back up, see what you did.
Right, you heard that, right?
You're in something.
I'm writing to her.
Yeah.
Yeah.
Control D should kick you out.
Oh.
All right. Substitutions. So inside VI, you can hit a colon,
You're the only one here that doesn't love somebody.
and colon like opens up a whole new aspect of the editor. So we'll spend about a week talking about regular expressions, but here's one thing you can do. Suppose that all right, hold on. All right. All right. Suppose I want to use print instead of printf for some reason, right? I can go through. I can find all my printfs and change them into print. Here's something else I can do. Colon $1, This means from the first line to the last line of the file. Dollar sign always means last. Substitute printf with print. And now all my printfs get changed to print. And maybe I wanted to use single quotes instead of double quotes. I can say substitute double quote with single quote. And this will only do it once per line. If I want to do it everywhere on a line that I find a double quote, I can say G at the end, which means make this global across the entire line. And now all my double quotes have changed to single quotes. Of course, that's not going to compile, but we're just playing with editing. So this colon is a really useful feature. And we'll talk a lot more about doing these substitutions. You can also say colon set, and you can see all kinds of options. And this can control how VI responds to things like tabs or backspace, or does it put numbers on the side, or things like color coding and so on. So there's lots of set options. We can also say something like colon VI dot bash RC. And even though I'm inside a VI session right now editing this file called temp, this will switch me over. Oh, let me save it. This will switch me over to editing a second file. So now I'm editing .bash RC, and I could say VI temp and go back to editing temp.
And that's
And-
not opening a new instance of VI.
It's the same VI, right? But it's remembering where I am, right? So I'm down here. Let's say I'm changing the name of this. And you can also switch to your other file by just doing Control-6. So Control-6 will take me back into bash RC, and Control-6 again will take me back to temp, and I'm on the same line I was. So you can go back and forth between files like that, which is nicer than closing your file and going back in, and so on and so forth. I can also, from the command line, say, let's edit two files, temp and bash RC. So it'll take me into temp, and then if I say :n for next, it'll take me into my next file. And then I can still Control-6 to go back and forth.
You can control what? 6?
Control-6. I
So
think
would
it.
you like copy from one file and then paste to another?
Let's see. So let's delete the files from there, and go into the other one and say paste, and there you go. So that can be
That's
useful.
really useful, yeah.
Yeah. You can also read from a file. So I'm in my bash RC, so let's say I want to read the contents of temp into my file right here. I can just say :r space name of a file, and it'll read the contents of that file and drop it into my current file right where my cursor is.
And that doesn't save it there, it just displays it?
No, it's actually in my file right now, so if I write this out, it'll actually save it. But I don't want to munge my bash RC. I also say : and do any command I want, so I can say : date, and it'll run the date command. And it'll hang out here at the bottom, and when you're done, you can hit enter and go back to your editing session. So if you got something in Unix you want to do, you don't have to exit VI, you can just say : we can also take the output of a command and pull it into our file. So I might say something like written on, and I can say : read ! So read the output from a Unix command, date. That'll run the Unix command, take the output, and load it into my file right where my cursor was. And now I can go up one line and say join, and now I've got a cool comment that shows me when I wrote this code. And you can read in anything you want. I can read who, and there's a list of everybody who's logged in the middle of my C code. All right, and exiting. So :W says write my file out to disk. Okay, and that's all it does. It writes it, but you're still in the editor. :Q says quit. Just exit. Don't copy my file to disk. Just leave VI. If you try to quit but you made some changes, it won't let you quit. It'll say you've got unsaved changes. If you really just want to quit, Q!. Okay, if you want to write and quit, you can say WQ. If you want to write into a different file, you can say write and a new file name, and it'll write it into there. There's all kinds of things like that.
What does :X do then?
:X I think is WQ. I've never used :X,
Okay.
but I see people use it. I think it's WQ.
Okay.
So let me show you the coolest one of all. So :split. :split gives you a split screen. And I could come up here and I could say, well, I want to exit. I want to edit bash RC :split. And then Control-W twice switches from one window to the other. So you can like move around here and do some stuff here, and you can copy and paste.
What are you gonna, what?
So you can keep splitting. So if you got lots of real estate on your window, you can do this, or just open multiple windows.
Or just open, could you have the terminal on one of them? Or is this all files?
So this is all just inside VI, so I'm editing files.
Oh, okay, got it.
But you can open multiple sessions to the server
I see.
if you want different windows. So you have a window for editing, a window for compiling, typically.
So if you're in VI and you wanted to open a specific file, you just have to use code to be like, split it.
Yeah, yeah.
Neat.
Yeah. And if you close these out, then that window goes away. All right, so I want to start looking at more Linux commands tomorrow and talk about some commands, talk about ways to put them together, and we'll build up from there. PA2